Welcome back. Today we're going to be talking about intervals of increase and constant intervals. So for today's agenda, I'm going to show you the strategy, go over some examples, I'll introduce some new notation, and then we'll end it off with talking about constant intervals. So here is the strategy that we're going to follow for these interval problems. So first, we got to establish that whenever we read a graph, we're always scanning the picture from left to right. So we're always scanning from left, and we're going to scan to the right. Okay, regardless of what where the arrows are pointing or where the jumps are occurring, we're always scanning from left to right. Okay, secondly, for these problems, we're going to look for places where the graph is moving upwards. So in other words, now we care about how the function itself is moving. So we're trying to look for upward movements, something like that, or you can even have like an arrow here, or you can have like a curve, something that represents an upward movement. Those are the places on the graph that we're interested in grabbing. And then finally, we're going to use the interval notation that we've been practicing for the last 11 lessons. So again, remember that brackets are associated with open circles. And also every time you use infinity, you gotta, actually never mind, that's for parentheses, and brackets are closed circles. Parentheses are associated with open circles, and whenever we have infinity, we have to close it off with one of these brackets here. So let's take a look at some examples now. So let's begin with this one. To remind you, we will begin by reading the graph from left to right. So let's begin scanning this. And then secondly, we want to look for places where the graph is moving upwards. So you see, as we begin to scan this graph, we immediately see an upward movement. And the upward movement ends right here at this break here. Because as soon as I begin scanning beyond this point, you can see that now the graph is moving downwards. So here, let me actually create those breaks here. But you can see that my break is going to end right there, and it's going to begin right here. So I'm going to highlight this in red. This represents an interval of increase. So now I have to represent this interval using interval notation. So we got to get the lower bound where the interval of increase begins, and the upper bound where the increase ends. So here we see that it begins at -1, and here we see that it ends at a +3. So sorry, it begins at -1, ends at +3, and using interval notation, we're going to use brackets here because of the closed points, and that would be the interval of increase. So let's check out this variation now. So remember that we're always wanting to scan the graph from left to right, and we want to look for upward movements because we want intervals of increase here. So let's begin. So here we can see that we're going downwards. So we're going downwards, and then here you can see that we remain neutral. And then once we go beyond this point, we see that now we see a nice increase. So let's highlight it in red. Okay, so now this red portion is an increase. Let's see if we can find another increase on this graph. So as we go beyond this red point, you can see that now we remain neutral again. And then once we go past this point, we see another increase. So let's go ahead and highlight this interval as well. So on this graph, we have two places in which this graph is increasing. So let's go ahead and label these. So I'm going to begin by creating my breaks so you can see explicitly where the increases begin and where the increases end here. So this one's going to represent my first increase, which begins at 2 and ends at 4. And then here, let me do it in pink, or actually I'm going to do it in green. Here's the second increase. We have it beginning at 6 and then ending at 8. So let's go ahead and write these in interval notation. So here I have the first increase beginning at 2 and then ending at 4. And then the second increase beginning at 6 and ending at 8, using brackets because of the closed circles here. Whenever we have more than one interval, we use a special kind of notation. So this is a perfect time for me to introduce that. So here we have this capital U, and that capital U is going to be denoted by union. So we use this notation when we want to include more than one interval. So on Go Formative, make sure that you use a capital U. So let me show you on the previous problem how to properly write the solution of this. So all we gotta do is just add a union sign in the middle, and this would represent the intervals of increase. Now the same principles apply to graphs where you have the endpoints going towards infinity. So for example, let's check this one out. So again, we begin by scanning our graph from left to right, and we want to capture all of the upward movements. So here we see that we immediately see an increase if we're going from left to right. Now please don't be deceived. Here we have an arrow pointing downward, so you may think it's decreasing, and that would be correct if we were reading from right to left. But again, we're reading from left to right, so this would represent an increase. So let's go ahead and highlight this in red. And now we want to continue to see if we have more than one interval of increase. So past this 2 point, we're see a decrease now, so we're going to ignore this. And you see that right here, past this point right here, we're going to see another increase, another upward movement that's going to go all the way up to this peak right here. So let's go ahead and highlight this in red as well. And now let's continue to go past beyond this point, and you see that we get a decrease. So our intervals of increase are this section and this section. Now we have to express this using interval notation. And to do so, I'm going to first pay attention to this arrow. And here, if we look at the left, you can see that we have a negative infinity right here on the left. On the right, we're going to have a positive infinity, but we don't really care about this part since this was a decrease and not an increase. So here, you can see that if I explicitly mark these breaks, our increase begins from negative infinity all the way to positive 2. And here, this break begins from, here I'll do it in green, it begins from 5, positive 5, to about 8.5 here. So 8.5. So let's go ahead and use interval notation. So here, interval, we got intervals of increase are going to be from negative infinity to 2, union 5 to 8.5. And that would be the interval of increase for this infinite graph. Now we can also apply these ideas with piecewise functions such as this one. So let's begin by scanning the graph from left to right. So I want to remind you that even though this arrow is pointing to the left and you might think that this is an increase, we established already that we're going to begin by scanning the picture or the graph from left to right. So from left to right, we can see that this is actually a decrease, so we're not going to pay any attention to it since our objective is to get where the graph is increasing. So we ignore this part, and then we have a jump discontinuity, and then here we can see that this is constant, this is neutral, so we're going to ignore it as well. And then we get another jump right here, and it's at this third piece that we see increase. So let's highlight it in red, and we're pretty much done in identifying the increases. The last thing to do is to represent it using interval notation. So here we see that the increase begins at -1, and since we have an arrow on the right, we can say that the right hand side is going to approach positive infinity. So the interval of increase in this situation is going to be from -1 to infinity. And there you have it.